You may have heard of a home on the range, but what about a home on Lagrange? In the late 18th century, scientists Leonard Euler and Joseph Lagrange each predicted the existence of various points between two large celestial bodies, where their combined gravitational pulls would provide the exact centripetal force required to orbit with them. This means that any matter at such a point would be parked, not moving relative to the two bodies. Well, these points do in fact exist. For any two-body system, there are 5. Let's take a look at the Lagrangian points, as they're called, between the Sun and a planet, say Earth. The first 3 points, labeled L1, L2, and L3, are located on a straight line from the Sun to the Earth. L1 is between the two bodies, L2 on the opposite side of the Earth, and L3 on the far side of the Sun. Points L4 and L5, on the other hand, are located along Earth's orbit, behind and before the planet. Each of these points form an equilateral triangle with the Earth and the Sun. As you may have noticed here, the center of the Sun isn't the same as the center of mass of the entire Sun-Earth system. This point, called the barycenter, around which everything in the system orbits, is actually located several hundred kilometers from the Sun's core. Take a look at L4. It has several predominant forces acting on it, one pulling it toward the center of the Sun and one pulling it toward the center of the Earth. Because it orbits on a circular path around the barycenter, you can also imagine it as having a centrifugal force urging it directly away from this center. While centrifugal force is technically a pseudo-force, it is this tendency that seems to pull orbiting objects away from the center of their path of rotation, and why you feel pushed to the outside edge when driving around a curve. Here, in a rotating frame of reference, we use centrifugal force to account for the point's circular orbit. When we resolve the two gravitational vectors into a net force, we see that it pulls toward the barycenter, and is equal and opposite that centrifugal force. Thus, the forces cancel out, and voila! The Lagrangian point stays fixed in orbit with the Sun and Earth. The story for the other Lagrangian points is similar. In each case, the combination of gravitational forces from the Sun and Earth counteract exactly the centrifugal force of the rotating point. However, while points L1, 2, and 3 are rather unstable, that is, matter in them can easily be jostled out of its stationary position, points L4 and L5 are much more stable. They're so stable, in fact, that physicist Gerard O'Neill proposed a plan in the 1970s for establishing inhabitable space colonies at L4 and L5 in the Earth-Moon system. But that's another story.